Alright, ladies and gentlemen, boys and girls, children of all ages, we're going to go over external wastegates, boost control, how it works, a little bit of theory, up and down. We're going to go from simple to more wild ways to control boost. Try to make this as linear as possible. So we're going to go right to how does the wastegate work, and then we're going to dive into like advanced ways boost control works. I think you can see that pretty well, huh? Yeah, we can see it kind of good. Yeah, definitely. Anyway, most conventionally, you know, if you're watching this, you're using like an external gate. This applies also to internal gates with a top and a bottom. Some internal gates have a top and a bottom port also. Some of them you can even separate and change the springs. Most of the time you end up swapping the entire actuator, but that's a whole other thing. So let's just jump right into how it works right now. So basically, in a perfect world, you're going to spring your wastegate here for approximately the amount of boost you want, and you can leave it go from there. You could spring for, say, 5 pounds. Your car makes 5 pounds. You can call it a day. So inside the wastegate, there is a top and a bottom, and there's a diaphragm in between. So when we refer to the bottom port, I'm using this VS44, makes it easy to explain. Bottom port, top port. And what happens is you connect the bottom, and when it makes enough manifold or turbo driven reference for boost pressure, it lifts, it negates the spring pressure, opens the valve, and exhausts or wastes exhaust energy to maintain the boost level. Anyway, if you want to add boost, you either need to spring up or you need to trick this entire, vacuum slash boost referenced mechanism. So understanding it makes it easy to understand how it works. So if you connect like a boost source from the turbo and go to the lower port on the gate, let's say you make 3 pounds. Cool, you make 3 pounds in your intake. If you want to raise that, one neat trick that usually works out, let's say you have an average build that doesn't have excessive back pressure or any other crazy shit going on. If you have a 2-port wastegate, top and bottom, what you can do then is you can split this reference and go to the top. Now once you have top and bottom, theoretically, on an average setup that's working well, you're going to have 3 on the bottom, and when you add 3 on top, pushing down, you essentially get 6. I mean, this is second grade math here. You get 6 pounds in the intake. So once you understand that pushing this back down negates the 3 pounds, that it has to make an additional 3 pounds to open back up. So what's cool here is now most China wastegate, China turbo setups this works with. Some they run away, but what you can do now is it's basically in multiples. It just keeps 1 times, 2 times, 3 times. So on a lot of setups, you could unplug the reference completely, and you would usually get triple, which would be 12 pounds. So no reference at all. What's going to happen here is the exhaust back pressure is going to push this open, and it should run roughly 12. Now, if you have a setup that's very efficient, that doesn't make a lot of back pressure, this will make more than triple. So that's one thing you have to watch out for. Some setups in particular that we just want to leave go, or if the wastegate's underneath the car and you're worried about losing your reference line, you can spring very low and run no reference at all. And what's going to happen is back pressure is going to open it. So what most people would think would be a catastrophic situation where you're running no reference line isn't really that big of a deal. Back pressure is going to open the gate and you'll be fine as long as you're seeing like a steady, non-creep, non-insane amount of boost. You're fine. We've done that many times. Just remove the reference totally. Other times, I mean, you have to watch out. If your setup is very efficient, it could run away. It could just be whatever the fuck it wants to do. Now, that's super simple mechanical ways. Now, if you want all the boost, you connect your reference right to the top. So any boost pressure it's making, it's shoving the spring back down. Now, sometimes we've had cars that only make like 1.5 pounds. We disconnect the reference completely, it makes 7 pounds. We put the reference on top, smashing the shit shut. It has so much back pressure that it only makes like 10, 14 pounds. Now you would think that would be, sometimes you would think this would be catastrophic, and most of the time in a good setup, it would be very bad. But it's funny, when the boost is low enough and the back pressure is high enough, you see a situation where that's fine. So that's one of those things we do on the dyno, where if we're not getting a lot of boost, I'll go whoop, like right to the top line or something ridiculous. And that's another reason why I use like shop air or CO2 based, which we're going to get into. And then now the next version we're going to talk about that I like to use is like a ball and spring, an inline boost controller. So you come out of the boost source and you go into, basically a ball and spring has a knob on one end and it has a body, and it's usually a T fitting, so there's a barb coming out of one side and a barb coming out of the other side, and in here is a plunger and a spring and a ball, and it goes into a little check valley. So what happens here is you're turning the screw in, and it is pushing, the boost source has to lift the spring pressure, and then it can go, then it can go to the middle port. So say you make 3 pounds and you put a ball and spring boost controller on, and you push this in until you get a little bit of resistance. Basically you're tricking, the amount of boost has to come up before the spring mechanism can open and you can get boost. Now, most of the time this setup works great. Like you put a 10-pound spring in, you want to run between 10 and 18, you can just push this guy down a little bit and you're going to get extra boost. You can keep turning it in. Sometimes they have a heavy spring, sometimes they have a light spring, sometimes they come with both and they're marked. I like to use, I'll put it up on the screen, I'll put them in the description, blast me right away if I miss. Alright, so very simply, this is just creating a restriction to generate more boost or air pressure to hit the reference before it opens early. That's really all it's doing, is fooling it. Now there are other ways for this to work. This is a ball and spring, and then what other people do is, there's many ways to add boost. So you can put what's called a bleed on, and what happens is you come off the turbo, and then you go into a bleed valve, which usually looks something like this. And it has a little knob on it also, and you'll come in, and then you'll come out of here and go to the lower port. Now, usually there's a needle valve in here and a seat, and when you start to open this, what it's doing is it's usually leaking air. So you're opening an amount of leak. Other people do this by, it's funny, you can put like vacuum T fittings on or use some sort of hose and you can poke holes in it. So you're letting out, say this wants to make a bunch of boost, you're letting out, let's just reference again, say 3 pounds. So you're letting 3 pounds out into the atmosphere. So what's technically happening is you're hitting the bottom with 6 pounds. So you're letting 3 pounds go, you're artificially adding double the boost there. And then what's neat is you can actually start to use them in combination. So that's a bleed and a ball and spring, so they both artificially, you either lose the reference or add to the reference. Now there's something else you can do, which is put boost to the lower, and you have 3 psi. Then what you can do is you can use a boost controller to add pressure to the top, to push the top down. So you can use like a high resolution compressor regulator. People are obsessed with using compressor regulators, but the issue there is for use with a compressor, it's made to go like 50 to 150 psi. It doesn't have a lot of resolution at low pressure. And what you're doing on a turbo setup is you want to add like a pound or 2 or 3, not 50 to 150. So you run into an issue where you're turning that thing and nothing's happening, still nothing, and then you have 20 pounds more than you wanted. So what you can do is, I link to this guy all the time, but this is a low resolution regulator. It's a 3 to 33 psi regulator. So a whole bunch of turns is like 1, 2, 3. It rises very slowly. It's easy to control a lower amount of boost. What you can do is you can put this in line up here, so you can have the little pressure gauge and then the knob on the top, and then you have boost coming in and then a regulated amount coming out. And what you can do is, since you have a 3-pound spring, technically at its limit here you can only add a 3 additional on top. But again, if you have an efficient setup, you can usually make a bunch more boost than you think. Now also, this gets us to our next point with electronic or other ways. So electronic boost controller, very simply, the simplest way that an electronic boost controller works is I like to use AEM True Boost. Put this guy down. And what's happening there is you have a little boost gauge with a computer in it, and you have the wires going to a Mac solenoid with 1, 2, 3 ports on it. And then the wires connect to the solenoid, and then you go boost in, and then you can use this to do the ball and spring method or add to the top because it has a 3-port valve. So in one of the configurations, this thing is normally open or normally closed. So what's happening here is if you run it straight through, it's letting the boost go through, say 3 pounds. So if you input 50% into the boost controller, it's closing that valve halfway. It's basically doing a pulse width modulation, and it's allowing half the pressure through. So it's going to add, say you're making 10 pounds and you put 50% duty cycle on. In a perfect world, you're going to add half of that 10. You're going to get 15. So as you get to 100%, you should see 20 pounds in the manifold. In a perfect world, if you don't have excessive back pressure or other things going on. Now, the other way to run this is electronic boost controller again. Still doing the same thing. What you have here is your turbo directly connected to the lower. You have electronic boost controller up here, with the wiring coming down, the 3 ports, and you're adding boost to the top. Now in this situation, you have to change this because the boost controller amount is the same. Either way, now at 0, this isn't adding any boost. Say you're making 10 pounds down here, and you add 50%. What it's doing is it's allowing 50% of the air out of the turbo to get to the top of the wastegate. So it's pushing back down. So you have an incremental where you can go up. Usually sometimes it's 1%. Some of these things like I think the Innovate or some other ones go 5% at a shot. And you can slowly add your boost in. Now what's cool about something like this, like the True Boost, is it's a boost gauge and the boost controller all in one. And it has 3 settings. It has off, which means the solenoid is off, so you're getting wastegate pressure. And then it has a A and a B function. And what's cool about that is if you have 10 normally, then you have A at 50%, then you have B at 100%. You can push and hold the button and it'll switch. So you can be flooring it, it's not going that fast. You can hold the button, it goes to A, makes 15 pounds. You can hold it again, it goes to B, that's 20 pounds. So it allows you to have, you can choose the amount of boost. If it's like a stock bottom end car and you don't want to be making 1,000 horsepower all the time and just, almost be chucking the rods all day, you can turn it up and down. Or it also has a function to do scramble, which a lot of boost controllers have a scramble function. We're going to get into that, so that's a good thing to show you on the lower end one. What's cool is it has a little wire coming out. Check out that handwriting. So what you have here is a scramble setting, and that has its own duty cycle amount. And it's either a power wire or a ground. When you ground that wire out, it runs the scramble amount for a certain amount of time, and all that's in the settings. Now, you can get really imaginative with this for being a simple boost controller. Say you have a TH400 and it has a micro switch on it, and when you hit second gear, you can leave on 10 pounds. 10 pounds in first gear, it spins with any more than that. You can set the boost controller to run 15 or 20 on scramble, and you can set up the micro switch to hit that in second or third gear. Alright, I keep hearing people like yelling outside. I don't know what's going on. Allentown things. Anyway, what's neat about that is you can have adjustable power level, like an expensive boost controller, which we're going to get into, for for some cars, this is great. It's very simple. It works great. I mean, it looks too dumb to work for most people, but it works great. You can adjust the amount of boost per gear with like a micro switch when you hit second or third gear, something very simple. And it doesn't need to be overly complex. It works fine. And then, as we dive into more of this stuff, you're going to run into another form of boost control. Instead of a 3-port solenoid, there's a 4-port solenoid, which what it does is the boost comes in and it goes to the bottom and the top at the same time. And as you open it, it starts to restrict the bottom and add to the top only. Now, I'm going to link a video. Jay from Real Street Performance does a better job than I could explaining the difference between a 3-port and a 4-port and how that works in like the import world and for overall boost control. And then the only thing that I can see an issue with that is sometimes the 4-port has resolution issues. Like a very small percentage is a lot of boost, which doesn't matter to some people. They want to run 60 pounds of boost. It's not that big of a deal. They spring appropriately and they find the sweet spot. But in my opinion, a 4-port, like you don't have a lot of resolution. Like 18%, no boost, 20% makes 20 pounds, and then 22% makes 30 pounds. Sometimes you lose a little bit of granularity there, and if you have a closed loop system, it might be fighting with itself to try to find it. It's not always the greatest thing. For a lot of people, it does work fine. Anyway, we're going to skip right on, and then this is a simple form of electronic boost control. What you can get into is electronic boost controller that does what's called closed loop, and you can, I haven't used enough of those to really give you a good idea other than ones built into the ECU. You can give it a target amount. Say you want to make 20 pounds in the intake and you have your solenoid hooked up like this. What it will do is there's a bias table built into the ECU which you can leave zeroed out. What it's going to do is when you start accelerating it's these 3 pounds, it's going to start adding a percentage until it closes in on this 20% target and then holds it. Now this is great for some cars, even stock like Subaru and Evo, other things like that have this stuff built in. You might not know. It has a target duty cycle amount that helps it get closer to target, and then usually, classically, they have a smaller turbo that punches good down low, and then you'll notice if you have straight wastegate hooked up, the boost will taper off when RPM comes up. It's a little bit small, so what happens there is what you can do is you can set the target and it'll add duty cycle and push the turbo harder to maintain a level amount of boost instead of nosing the boost off as long as the turbo can sustain it. Some of them nose a little bit at high RPM. Sometimes you start generating a little bit more back pressure, and even though it's the same amount, it's just pushing the gate open more and you're losing boost pressure. There's a whole gambit of things that can attribute to what's going on in that scenario. A lot of times the turbo's too small. Turbine's choking off, back pressure is doing it, the compressor can't get enough air out, all of the above. 1.8T is like a classic version of that. A 1.8T will, you can just pin the fucking turbo and it'll go, it'll make 25 pounds, and then before 5,000 it's already at like 14 pounds, 10 pounds. So anyway, a closed loop electronic is going to hunt for a target in so many words or less. It's always going to be looking for a target amount of boost, and it's going to try to maintain it. Now there can be, 1, 2, 3, 4, 5, 6 tables attributed to maintaining that target as far as a PID loop, a bottom line duty cycle like reference table that it can use that says at 14 pounds, the ECU, I approximately need 50% duty cycle here and 75 here, so the closed loop has to work not as hard to maintain the boost. You give it like a baseline. All of that, depends on your system, what controller you're using, its feature set, yada yada. And then what we get into next is an interesting system like we implemented on a lot of race cars. People don't know much about it. It's CO2 or like supplemental air or whatever you want to call it. Most companies call it dome control, and there's a reason for that is we're going to get rid of all the reference lines here, clean this up. Now very simply, the dome is here. The top of the wastegate is the definition of dome control is controlling the amount of boost in the top of the wastegate to get your desired result. So what's happening here is, say you have your lower reference line hooked up like normal. Now, you have a race car. Let's reference Mark's 427 twin turbo Camaro. We put 3-pound wastegate springs in. Some people are like, man, isn't 3 pounds pretty low? Interestingly enough, a lot of race cars leave on less boost than you would think. They don't leave on 30 pounds or some crazy amount. They will dig the tire as early as possible and then ramp the boost in. Now, it's difficult to spring a car for every situation that you might encounter while racing, and you lose some of that adjustability, the resolution down low, a granular way to add steps in boost. Like I said, with the 4-port, sometimes the percentage is too much at times. It's hard to get exactly what you want. Now this is where dome comes in. Now what's cool about dome control is you have a CO2 tank and you have a little regulator on it. You have 1200 psi of CO2 in there, and it's going out of the regulator and it's going into 2 solenoids, and one is the vent and one is the fill, and they're both connected to this. This is regulated to say, if you only want to add 50 pounds, let's say 50 pounds. So you regulate this guy, I said 150 here, 50 psi. So there's 50 pounds available to the vent and the fill solenoid. Now out of the fill, it goes to the top, and the vent just vents into atmosphere. So what happens here is, you spring for 3 pounds, the lowest amount you ever want to make. So that's what we have in Mark's car, 3 psi. Now what's neat about this setup is, if your car has appropriate sized turbos or not, let's just say frame of reference 1-to-1. If you make 1 pound of boost, you have 1 pound of back pressure. If you make 3 pounds of boost, you have 3 pounds of back pressure. So this is an ideal situation for us to learn in. So say the car makes 3 pounds. What happens here is, if we add 1 psi up top, then we get 4 pounds in the intake. And on a 1-to-1 setup, this is linear. And now what's going to happen eventually is, people talk about drive pressure. That's actually the name for it. I'm from Pennsylvania here. I hear too many people say back pressure or exhaust back pressure or exhaust or post-turbine or any of that stuff, pre-turbine. Anyway, there's the pressure in the exhaust that's driving the turbo. And what you're going to see is, at some point where the turbo is going to give up is, you're going to be backing it up, and the exhaust pressure is going to go up, and the intake pressure, it's going to become nonlinear. You can tell you're still being efficient because it's not clogging up the motor, 1-to-1, 1-to-1, and then at some point you're going to get 20 pounds of boost and 30 pounds of back pressure. And then you're going to go 25 pounds of boost and 40 pounds of back pressure. It's going to start to run away. What's happening is you're clogging up the works. You're holding up the exhaust trying to get out of the motor at that point. You need to reevaluate your camshaft or your hot side or your turbine. A lot of stuff goes into that mathematical situation, but let's dive back into how CO2 works and why people like it. Say this car leaves great. The track kind of sucks. Car leaves great. 4 or 5 pounds of boost. So you can say, hey, Mr. CO2 controller brain, on the trans brake, I want to leave on 5 psi. And then all these systems like an AMS 500, AMS 1000, a lot of other CO2 based boost controllers, they have a chart. And you can chart in the amount of boost you want to add based off of a timer. Most effectively in drag racing, you're using a timer. And how you start this timer is with usually a trans brake button. Almost all race cars are using some sort of trans brake button. So they'll have like a 12 volt in, and you take the trans brake power wire and run it to the AMS or the Holly or whatever you're using that does built-in CO2 control. And that's your marker to start the timer. And then what will happen is, you have a little chart in the little display. You have a little 0 seconds, 1 seconds, 2 seconds. This stuff never ends. So what happens here is you have the trans brake set at 5 pounds, and then you have 5 psi, 10 psi, 15 psi, 20 psi, 25, 30. Let's just say we got a race car here, and you want to have all your beans in by 2 seconds. On Mark's notchback, to go 7s, we would leave on 8 pounds and go to 22 pounds of boost in 1.1 seconds, but let's just do a very simple explanation here. So we're going to go 5 to 30 pounds over 2 seconds. So what starts this timer is when you release the trans brake on your external boost controller that does CO2 or your built-in controller that does CO2. And you have a reference of 50 pounds, and then you have a pressure sensor screwed in here going back to the computer that's telling it the dome pressure. So what you're charting on your boost controller is this is requested dome pressure. You're not requesting intake pressure in this scenario. You're telling the computer what you want in the top of the wastegate. So you say you want 5 pounds. So when you go on the trans brake and you put your foot to the floor, it sees 3 pounds. It knows you want 5 in the top of the dome. So it pushes, it uses the fill, and it puts some of the CO2 pressure in the top until it hits your requested, and then it vents and levels it off. Now what's cool here is when you let go of the trans brake, it starts this timer. And the timer says, I want 10 pounds, 15 pounds by 1 second. So 1 second in, it has filled the dome to fill the request. Now what's neat about this, the whole idea of this is some of these cars are running 50, 75 pounds of boost, but they leave on 3 pounds to set the tire. You might not think that they leave on boost that low, but they do sometimes, depending on the track situation. And then what happens here is if you are recirculating, if you're taking the turbo air and recirculating it, like I mentioned with the earlier boost controllers, the issue there is sometimes you can't get, say one of these cars wants 50 pounds of boost at 300 feet out. It can stick everything from 300 feet out. You can go 50, 75, bam, at 300 feet you can't hit the thing with enough power. You run into an issue where when you're recirculating that air, it takes too long to build up the air pressure that you need. Everything has to keep working as a catalyst together. You can't get the boost you want. Whereas CO2, you have artificial air. You can pound the thing with 50 pounds on top of the gate. Now what's neat about that too is say that you can't get the intake air or your turbos are 2 to 1. You can re-regulate this to 150 psi and you can slam your gate with 150 pounds on your scale. Say you can't get the boost you want out of 50 psi. Knock that thing to 150 pounds, slam the top of the gate down shut. Most of the time when you get over 2 to 1, your turbo system, you're not going to make the power anyway, but that's beside the point. Some people are still going fast, pushing the shit out of their combo. It all depends on what you want to do with it. So what's neat about this is, say we go to the track, leaves off the brake, it runs through its timer, it adds the boost, we put 30 on the top, that gets us 27 in the intake, car flies. Now, next day has shown up, track isn't that great, people are spinning 300 feet out. What you can do is you can come down here and you can go into your chart and you can leave on 5 and you can change that ramp. What we did here is we pulled a whole shitload of power out 1 second in and brought in almost all of it by 2.5 seconds. So this is how this is traction control basically, because the people I know that go really fast don't really use traction control, because all traction control does is slow the car down basically. There's a lot of uses for traction control on like a road course or in the snow or something like that, but in a race that's 3.5 seconds long, it's either going to get there or it's not. If you're pulling power out of the car, you're going slower than the other guy. So you just got to set up the car and everything else and try to get it hit with as much power as possible. So your traction control is basically how much power you're hitting the car with. And then what's neat here is this might be 600 horsepower, this is 1200 horsepower, and this is 2200 horsepower. So you're slowly feeding the power in, and you can change these ramp rates. Now, this is what's so cool about CO2. If you have a back pressure situation that sucks, if your boost is so low that your car struggles to clear that hump where you can't get boost in fast enough, a lot of interesting things. And then what's neat about this is you can program a ramp rate, and you can set up as much power as you want to, or you can close it off, or whatever else. And I did say like a CO2 tank, but what you can do is some people change this out with just like a Harbor Freight compressor tank, or like for like a low rider with airbags, and they do a little compressor, you know, and they pump air into it. Now, all you have to do is make sure that during a pass you don't bleed off enough that you run out of boost. But I mean, it depends on the volume you're using, etc., etc. I know some people that do that. It does work fine. Plenty of people seem to like the CO2 because it lasts forever if nothing in your system is leaking. But all of that can be done. And other ways you can trigger this setup is, I know you can set it up to do by mile an hour with a lot of setups. So you change this time based. You can do mile per hour, and then you can go like 10 miles an hour to 200 miles an hour, and as the car accelerates it'll add boost. I mean, once you start to understand how this works, you can see how there is a lot of benefits to a situation like this, where you can have a 1 pound spring in the car and still run 60 pounds of boost 2 seconds into your track run, and you have this kind of granularity. And what you can do in almost all these systems is change this to 6 seconds, and then you have a 6-second ramp, like if you have a half-mile car, or if the ECU can support what gear you're in. It has like a gear position sensor. You can say first gear, second gear, third gear, fourth gear, fifth gear, sixth gear, and you can add the boost in. The only issue probably with something like that is at some point you're going to have third, fourth gear with a car that has 1,600 horsepower. You're going to be able to hit it with a ton of power in fourth or fifth. And then you have a traction limitation, whereas if you're putting it in by mile an hour, you're slowly feeding the power. When you have a gear change and you go from 800 to 1,600 in the next gear, it might upset the car because you're changing the gear, then you're just blasting it with a ton of power. So you can see where the time-based or mile per hour based curve coming in more softly makes a lot more sense. So I think I covered a lot here. And then normally what I do at the dyno, or what I like to do if someone's bringing a car, is I will tell them to spring purposely low, and then I will bring my regulator, and then we will just add pressure to the top instead of dealing with a boost controller or something else. A lot of times there's a lot of unknowns. It's someone's first car. They're not sure exactly what to do. So I'm like, there's no harm in springing it kind of low, seeing what it does, making sure everything works, and then adding the boost with the regulator, and then you can spring it later once we understand. If it has a lot of back pressure, you can overspring it. If it doesn't have much back pressure, you can, underspring it. But I think I covered everything. That is essentially how all this works. Now, you can understand if there's too much in the dome, the vent will alleviate pressure to get it back under control. And there's also ramp rates and how much PSI per second that it'll allow. It gets very crazy. If this is your first introduction to it, there's a lot going on. But hopefully it all makes sense. This is how a lot of this stuff works. If you guys have any other questions, I think I did a pretty good job for not pre-gaming or anything. But that's essentially how all of this works. Let me know if there are questions. If this was okay, let me know if I did a good job explaining it, if it makes sense, or if you're more confused. Either way, just let me know. If there's questions, I'll try to answer them. If you're interested about a product that does this, people can post it, or I will do my best to link it to you. A very popular one in the racing world is a AMS 500, 1000. I think they came out with a 2000 now. Each one with its own feature set. I think the biggest thing with an AMS 500 is it only has so many plots. It does like 5 plots. And then an AMS 1000 has like a much more linear curve you can put in, like a TI-83 graphing calculator that you can put in like 20 some points. So if your car struggles with traction, you can really get detailed with where you're putting the power in. Other than that, that is all. Class is dismissed.